Welcome. My name is Ron Papa Schmidt, and I'm the creator of the Net Zero Now YouTube channel. This will be video number 3. It'll be in the Why section, and the title is going to be Why Now. It also will be a foundational core video. And this is probably the most important video that I'm going to have on this channel. It may be a little bit long, but please try to hang in there to the end. Now, in this video, I'm going to try to do 4 things I want to talk about. But number 1 I want to talk about first is I've created this video 7 in the Future Hope Act section, and it's called My Climate Family Tree. And I would like you, if at all possible, for you to basically look at that video first before you proceed with this video. And in there I have you sort of creating your own personal climate family tree. I'd like to have you do that before you watch this video. Now, this video is also going to do a couple of other things. I'm going to do a recap of 2A and 2B, which really address why we need to get to net zero greenhouse gases. Now, if you've just recently watched those videos, you probably don't need to watch them again, and you can skip that section of the presentation. And to make that easy, what I did is you saw this sort of confetti that came down when we got to this slide. Well, what I've done at the end of that section, I've come down with, I have a transition slide, and I show that confetti for 10 seconds. And the reason I did that is you could sort of advance through this slide, the next couple of slides I'm going to go through, and get to that video, and you could easily recognize that, okay, I'm at a transition point and stop there. Now, the reason I included it in here is that some people may have come to this video without looking at that, and other people may have looked at those videos a long time ago, and will need this refresher to sort of understand what I'm talking about in the latter part of this video. The next thing I'm going to talk about is current and projected average surface temperatures. And to some extent, I've talked about some of that in other videos too. And if you've watched them, you may want to skip through that particular section. And at the end of that section, again, I have another one of these 10-second confetti kinds of slides there that act as a transition. And I did that so you can easily, as you advance through YouTube, you can get to the right slide. Now, section 4 is really the guts and the most important part of this presentation, and it is probably the most important section in the entire Net Zero Now YouTube channel. And in that, I try to present the case of why we need to get to net zero greenhouse gases now. And by now, I mean as fast as humanly possible, like a worldwide all hands on deck effort to do that. And I understand it's going to take time. I understand it's going to take money, but we just need to get after it. And I think you'll understand why as we proceed through that section. So let's begin. So here's a recap. And so of session 2A and 2B, why we needed to get the net zero greenhouse gas emissions. And the conclusion we came to really was that it was really population growth and human activities, like primarily the use of fossil fuels, that have raised greenhouse gases to dangerous levels. And you can see that by 2 illustrations. Well, if we start the illustration in the upper left-hand corner, you'll see this chart, which shows carbon dioxide levels from 1880 to, in this case, 2021. And that is the yellow line. And you can see that in 1880, we were under 300 parts per million. Now we're over 400, and in fact, the latest numbers I saw, I think, indicated we're about 430 parts per million. And then you can see what's happened to temperatures. And you see there's a strong correlation there. And then what we talked about extensively in videos 2A and B was how the chemical structure of greenhouse gases worked. And so I think after you understand the science, you can really say that this really is causal in nature. But the other thing we noticed was that population had also grown during this period of time. And like in 1960, when I was graduating from high school, there were about 3 billion people on Earth. In 2024, there were 8, and we're projected to go to 9.7 billion people on Earth by 2050. What does that mean? Well, first of all, every human being, now if you live in a highly industrialized country, you probably generate much more greenhouse gases than somebody else does, but every human being generates greenhouse gases. And our transportation, the food we eat, just living our daily normal lives. So what does this also mean? Well, if our population is growing, and it's going to grow in the future, if we want to get to net zero greenhouse gases, that means we're going to have to probably significantly reduce the net amount of greenhouse gases that each person on Earth is generating. And so we need to take into consideration the fact that population is growing also. And then the other thing we talked extensively about in those videos was the core science, and how there was really basically, even among climate skeptics, there's really no disagreement on the core science associated with climate change. And we talked about that extensively. We talked about what greenhouse gases were, what the percentage was of the atmosphere. We talked about their molecular structure. We talked about how sunlight comes to Earth as a shortwave radiation, and then some of it gets reflected directly back into the atmosphere, out into space rather, and most of it gets absorbed in the Earth and then gets radiated back into the atmosphere as long-wave radiation. And we talked about how that long-wave radiation interacts with the greenhouse gases, and that was explained through as we talked about the quantum molecular structure of greenhouse gases and how they worked and how they interacted with that long-wave radiation. And we also talked about how we measure the amount of greenhouse gases in the atmosphere. And so that's what we covered in those sections. And again, there is just I don't think there's any disagreement at all among even the skeptics about these basic elements of greenhouse gases in the science. And then the other thing we talked about is how what's happening now is different than what's normally happened in the past. And we did that by showing this illustration on the lower left-hand corner, which tracked carbon dioxide in the atmosphere for the last 800,000 years. Now, we have trouble relating to 800,000 years. So let me just say that Jesus was born 2,000 years ago. We're talking 800,000. I mean, just think of the changes that have occurred since Jesus was born. And you can see, if you look at that graph, you can see we generally stayed within a range between just under 200 parts per million to 300 parts per million, almost that entire 800,000 year cycle. And we actually call that ice age cycles. And actually those fluctuations there, we were able to explain through something called the Milankovitch cycles. But you can see how currently the arrow is just going straight up. And you can see that maybe on the graph on the upper part of this chart here, which shows what's happened since the Industrial Revolution. So what we're seeing now is just significantly more greenhouse gases than we had in the atmosphere ever had for the last 800,000 years. Okay? So this is not part of the normal change cycle that's going on. And then the other thing we did, because we talked so much about carbon dioxide, because that's where the records go back, we just showed these other graphs here of other greenhouse gases too. So the chart to the right, you can see it shows temperatures are going from the lower left to the upper right, right? And then the second one with yellow shows carbon dioxide. You can see that follows that path. And since we started measuring methane and nitrous oxide, you see they look exactly the same. All these charts look the same. Okay, they start in the lower left-hand corner and they go to the upper right-hand corner. And it shows no matter which gas you're talking about, we really have a problem in all of them. And then to talk about that just a little bit more, we identified the chart on the left here on the top, what the greenhouse gases were, what the percentage is in the atmosphere. And then we had the GWP, the greenhouse warming potential of a greenhouse gas. And so carbon dioxide is shown as 1. If you look at methane, it shows as 28. So what that's saying is that methane has 28 times the warming power of carbon dioxide. And so the other thing that's important is how long does it stay in the atmosphere? Well, carbon, it turns out, some of it, it's got varying life cycles. Some gets out of the atmosphere really quickly, but a lot of it stays there for up to 400,000 years. So that tells you need to be real careful about the amount of carbon dioxide you're putting in the atmosphere. It's not going away anytime soon. Not in our generations, your kids' generations, your kids' kids' generation. You get the point. Now, to prove the point, scientists have said they estimated that we put, I think, 1.8 trillion tons of carbon dioxide in the atmosphere since the Industrial Revolution. Of that, they estimate about 1.1 trillion tons is still there. So we got to pay attention to this, folks. Now, methane, if you look at that line, you see it's 16% of the atmosphere, 28 times more intense. The good news here is that it only stays in the atmosphere for 7 to 12 years. So we're able to do something about methane and dramatically reduce it. We could flush that out of the atmosphere fairly quickly. And then we get the nitrous oxide. And while it's only 6% of the greenhouse gases, it has 265 times the warming potential of carbon dioxide. So we've got to be really careful about the amount of nitrous oxide getting into the atmosphere. And it stays there for over 100 years. So what kind of a conclusion did we come from that? Well, the conclusion we came to was, number one, is that the level of greenhouse gases, now technically it would be the sum of the greenhouse warming potential of greenhouse gases, okay, in the atmosphere that influences global average surface temperatures. You could probably say if you understand the science, you could easily say causes global surface temperatures to increase. There's a direct correlation there. And the other conclusion we came to, the only way, and I mean the only way to prevent temperatures from going up in the future is we've got to get to net zero greenhouse gases. Now that doesn't mean, if everybody wants to drive a gas-guzzling mini truck in the world, they can't. It's just that, so that's going to put a ton of greenhouse gas in the atmosphere. What we need to make sure is then we're getting to have some other mechanism to pull it out of the atmosphere. What's important here is we need to get to net zero. And finally, let me just illustrate that by what I call the bathtub effect. Maybe this will help you understand this concept. So if you take a look at a bathtub, think of it as, maybe the shower is sort of emitting greenhouse gases. And they go into the atmosphere, the bathtub, and sort of the level of water in the bathtub is the amount of greenhouse gases we have in the atmosphere. And then you have a drain where some are coming out. Now, during these life cycles, we look like every 100 years we go through these ice age life cycles. Sort of what's really happening is that the amount of greenhouse gases going into the atmosphere is sort of the same amount that's going out of the drain. Yeah, there's normal fluctuation, but that sort of stays about the same. What's happened recently is that the amount of greenhouse gases has just gone up dramatically, far exceeding what's coming out of the drain. And so what's happening is the level of greenhouse gases in the atmosphere is going up, just like the water in the bathtub is going up. What does that mean? That means today, you saw what happened in 2025, right? And as I'm recording this, Melissa just happened and just wiped out Jamaica and caused significant damage to Cuba. Fortunately, it missed the United States. Look at the amount of damage that did. So in 2025, we also had the Palisade fires, we had the Texas floods, we had tornadoes. You all know all that stuff, right? That's the best it's ever going to get. For the rest of our lives, our kids' lives, our grandkids' lives, our kids, our grandkids, kids' lives, their grandkids, kids' lives, etc. It's going to get worse every single year. If you don't think that's significant, think back to 2014 and look at 2024 and 2025. Look at how much time we now spend talking about our weather. We never used to. That's just going to get worse every year. And the only way we're going to stop that is getting to net zero. Okay, so here's our transition. Okay, we finished the recap here, our 10-second thing, so hopefully the people that are fast-forwarding got there. So here's the, so now we're going to talk about current and projected surface temperatures. And again, some people may want to skip this section, so we'll have another one of those confetti things at the end of this. And so what this shows here is that if you see this map, and I've shown this in other presentations, so what it really shows is this shows the average surface temperature around the globe. And you can see that in 2024, we reached 15.1 degrees Celsius. And in 2014, we were 14.6 degrees Celsius. So that says in the last 10 years, we've gone up a half a degree Celsius. Now, since most of us in America can't relate to Celsius, I thought I would convert it to Fahrenheit. And that says at the end of 24, we were at 59.2 degrees Fahrenheit. 10 years ago, we were at 58.3 degrees Fahrenheit. So we've gone up 0.9 of a degree Fahrenheit in basically the last 10 years. That's quite an increase. Now, take a look at, it so happens that by coincidence, that 15.1 is exactly 1.5 degrees Celsius from pre-industrial revolution. Now, most of the stuff that we see, you see them talking about climate, they talk about 1 degrees, 1.5 degrees, 2 degrees Celsius, 3 degrees Celsius, 4 degrees Celsius, etc. Well, this is 1.5 is equivalent to that. And then we had the Paris Climate Accords, which were signed in 2016. So they call it the 2016 Paris Accords. That means the actual science that they were doing had to be done in 2014 or earlier. At the time, everybody agreed that we didn't want to get to 1.5 degrees Celsius, but everybody sort of concluded we probably couldn't prevent ourselves from getting there. So they said, well, let's make sure we don't get there before 2050 because it has such dire consequences. And then they said, yeah, we'll sort of hit the maximum of 2 degrees. We don't really get to 2 degrees ever, but if we do, we want to make sure we at least prevent ourselves from getting to 2 degrees before the year 2100. That was signed, so some of the science was done in 2014. That means that 10 years later, basically, we've already gone up to 1.5 degrees Celsius. So we're there, roughly about 25 years early? Wow. If you just assume that if we went up a half a degrees in 10 years, let's assume we can go up another half degree the next 10 years, that would say we'll hit 2% by 2035. 65 years early. I mean, you see how fast we're moving compared to where we said we wanted to go? Now, I just want to show this slide quick because I can't tell you how many emails and comments I get from people that say, well, yeah, look at this. You know, in such and such a place, in 1888, temperatures were higher than they were today. Clearly, temperatures aren't rising. That's not how this works, folks. When we're talking about average temperature, they take the average temperature around the globe, over water, over land, in the Arctic, etc., and they chart it. So here's separate things. I just want to show you this one to show you that what we're talking about is the average temperature, and also show you can see that they're all increasing. But notice that we're increasing over land faster, and also we're really increasing faster in the Arctic, and that in turn has some really significant implications that we'll talk about in some other presentations later. And I just want to quickly show you this graph because this really caused me great personal confusion for months. Because every time I read an article, sometimes I'd hear that temperatures was 1.2 degrees Celsius, and then I'd hear it's 1.5 degrees Celsius. I do Google searches. Sometimes it would come out 1.2, sometimes it would come out 1.5. And it sort of seemed like They were coming from the same sources. Like I couldn't figure out how can we be that much different? What's going on here? It wasn't until I really found this website, zaclab.com, where they show the exact details of how all these different calculations occurred, that I found out when they're talking about 1.2, they're talking about the 60-month moving average. And when they're talking about 1.5, it's the current month temperature. So it turns out that the current month is 0.3 of a degree Celsius, or 25% higher than the 60-month moving average. That's crazy fast. Just think how fast we're moving here, folks. And I wanted to point that out. So in case, to tell you, number one, if you're looking at anything, you see all these numbers, you're getting confused by the numbers, what's probably going on is they're using different calculations, and you need to understand what they're talking about. And second one, I just wanted to mention, in case somebody wants to check me out here, and they run across the 1.2, I said, this guy doesn't know what he's talking about. So that's why I wanted to just also show that too. Now, so what about projected things? So what I said, so if we went up by a half a degree in 10 years, let's assume we do that. When do we come to these key points? When do we get to 2 degrees Celsius, 3 degrees Celsius, and 4 degrees Celsius that the world talks about all the time? And I'll show you the Fahrenheit equipments there. Well, it turns out we get to 2 degrees in 2034 if we keep at our current path. We get to 3 degrees in 2054, and we get to 4 degrees in 2073. Is that a reasonable assumption? Probably not. My thing is probably conservative. Why would I say that? Well, if you look at climate models, every time I look at a climate model, they tend to miss. And every time they miss, they're always underestimating the pace of change. Some of that's explained by what we'll talk about in points 3 or 4 here. The second thing that's going on is our current political leaders in many industrial countries, the major polluters, have either de-escalated or reversed climate actions. That's true in the United States, but it's not just the United States, it's other countries around the world too. And it's true of a lot of corporate leaders are doing the same thing, folks. So that says we probably will possibly accelerate the amount of temperature increases that are going on here. Now, there's also this concept called feedback loop, which will accelerate it. And these, for example, will increase greenhouse gas. For example, the deforestation of the Amazon rainforest, the Greenland ice sheet is melting, permafrost is melting, we're having more forest fires, etc. And I'll talk about that in one of the science videos, how that all works. But let me just give you a quick example so you can maybe appreciate what we're talking about in terms of a feedback loop. So right now we're actively deforesting the Amazon. And so what happens when you do that? Well, the Amazon and trees act as a carbon sink. They pull carbon dioxide out of the atmosphere. So if you cut down trees, you reduce the amount of carbon we're pulling out of the atmosphere, which is bad. But then something else happens. These trees really are a storehouse of carbon. So what do we do with them? Well, they either decay or we burn them. And what does that do? That releases more carbon dioxide into the atmosphere. And then the next thing that happens is then we replace the activity where we had the land on which we had these carbon sink going on. Now we're replacing with activities that generate greenhouse gases. Generally, in this case, it's either farming, but a lot of times it's farm animals, beef and cattle and stuff like that, which generate huge amounts of methane and other things. So you can see how this just accelerates the whole warming process. Because what we once was a sink, we're turning into a generator of greenhouse gases, plus a reservoir there, we're putting that into the effect. We're putting that carbon dioxide into greenhouse gases in the atmosphere. And then there's things called cascading feedback loops. So if you take a look at the Amazon, what's happening in these different subsystems also influence the behavior of other subsystems, so you have this cascading effect through the environment. And that's covered in the science section, so we'll talk about that in more detail later. So here we go through another one of these transition phases, okay? Now we're at the real meat of this presentation. Why we need to get to net zero greenhouse gases now. And for those that skipped, I just want to show this quick chart here that says, you can see from this chart in the last 10 years, we've increased temperatures by 0.5 degree centigrade or 0.9 degrees Fahrenheit. So in the previous section here, we talked about what happens with if we continue at our current pace. When will we hit 2 degrees, 3 degrees, and 4 degrees Celsius? Now, if you take a look at the far right-hand corner, one of the other things I said, well, what's an accelerated rate? Well, I thought maybe one way of doing that would be to, if you take a look at the 10-year thing, last 10 years, you see we had 2 COVID years in there. So if you eliminate the 2 COVID years, the source of the average, we would say we really would have gone up 0.9 of a degree Fahrenheit in 8 years. And so I just used that for the next 10 years and then just assumed every 10 years thereafter we just went up 0.1 of a degree Fahrenheit every 10 years. So if we do that, we get accelerated growth that says we'll hit 2% in 2034, 3% in 2047, 4% in 2067. So maybe the truth is somewhere between there, although it's possible that even my accelerated growth rate is too conservative. But it'd probably be between there. So what does that mean? So what happens when temperatures reach 2 degrees Celsius or 60.1 degrees Fahrenheit? And what you see here are the results from ChatGPT. And let me talk about how we got there with that. I was originally using this material for a presentation I was giving. I think it was in April, and this was in late February. I started looking into this. I said, well, you know what I ought to do is somebody's going to go check ChatGPT to see what they're going to get. So I thought, okay, well, let me go verify what I think's happening, because I had reached these same conclusions from just looking at all the material I saw from where scientists were talking about what was going to happen at these different levels. And it turned out GPT sort of said the same thing. And so I'm thinking to myself, I wonder, though, if this is accurate. I wonder if the algorithms are feeding me different information, because I'm obviously doing a lot of inquiries about climate change, so you can see that I'm probably very interested in that subject. So they would logically think, I have a bias, so they may want to be trying to feed me information that would be different than what they would feed to other people. And I so happen to have a blessing of being in a group of people where we get together every week and talk about different subjects. And it's a very diverse group. So within the group, we have, I know, one climate denier, one person that's very skeptical, and then we run the whole range, and I'm probably the most passionate about climate change in the group, okay? But we all thought this would be a really interesting exercise. So each person took the same question and entered the information into the particular, whatever their artificial intelligence thing they were using, that they used. And we then, everybody took their results, printed them off exactly, sent them to me. I sort of put them all together so we could sit down and discuss it. And when we found out that basically the answers were all the same. I mean, there were subtle little differences. One thing didn't quite include this. The wording was slightly different. They may have emphasized one sub-point more than another, but basically the message was the same. And it didn't seem to matter who was submitting the material. So it didn't look like there was a bias there. The other thing it looked like is that maybe it was regenerating the answer each time, because the answers were never, the wording was never exactly the same for anybody. Or maybe it's just that we use different search engines. I don't really know how that all works. But then, so I decided to use ChatGPT instead of my thing. Why would I do that? Well, if I come here, I was speaking publicly, and I say, Ron Schmidt thinks this. Well, let me see, what kind of a science background do you have, et cetera, et cetera, et cetera? Nobody would believe me, okay? Where ChatGPT sort of represents because they look at all the articles out there, represents the consensus, basically, of the scientific community. So I thought that was infinitely more credible than me. So therefore, I decided to prominently use ChatGPT. And by the way, these answers here came from somebody else, not me, because I didn't want to use the material I got just in case there was some bias associated with that, although we couldn't see any. And I identified the date at which we got that response. We got that response on March 8th of 2025. And this is it word for word. We didn't change a word on this. And what did it say? It says that 60.1 degrees Fahrenheit, or 2 degrees Celsius, the world will see catastrophic and likely irreversible damage. It's kind of shocking. Because that's maybe less than 10 years from now. And it goes on to say, and while 1.5 degrees Celsius and 2 degrees Celsius of warming are dangerous, the extra 0.5 degrees Celsius represents a significant increase in human suffering, economic cost, and environmental destruction. And as I mentioned in the other section, but in case you missed that, just take a look at the weather reports and what's happened in 2025 around the world. Go back 10 years. I mean, look at the amount of time the major networks are now spending talking about their nightly newscasts, ABC, CBS, I mean, it doesn't matter. How much time they're spending on weather-related events. About 10, 15% of the actual news content every single day? That didn't happen 10 years ago. Why? Because there's a significant increase in impact, and that's what a half a degrees looks like. Well, the impact continues to escalate the higher you go. So in the next 10 years, we're going to really see some really significant weather impact, right? And the other thing, you need to watch, if you have some doubt about this, in video 4C, which I've listed, we talk about the structure of Earth's climate systems and tipping points of those systems and cascading tipping points. Once you see that, I think it will become very obvious to you why it may be possible that we will not only see catastrophic impact, but human beings may not be able to reverse the damage. It may be irreversible. Okay, let's continue. So what happens at 3 degrees Celsius or 61.9 degrees Fahrenheit? It says the world at 61.9 degrees Fahrenheit, they call it a nightmare scenario. Let me say that again. A nightmare scenario. And it goes on to say, the world will become vastly more hostile to human civilizations. Cities, economies, and food systems will struggle to function, while ecosystems collapse at alarming rates. Mass migrations, war, economic clashes will reshape global society, leading to unprecedented instability. Avoiding 3% Celsius warming is critical. Does that seem plausible? Let me talk about that in multiple ways. You know, look at the crisis we've had in the United States as a result of immigration, right? Been pretty ugly. You know, I think at the peak we were getting close to 100,000 a month, and so let's just say roughly. Okay, so in the course of a year, at its worst, we got a million people into the United States. And look at the chaos that caused in this country. What the scientists are telling us is that maybe 3-4 billion people, around the world are going to be starving and everybody have to migrate. Look at the chaos, 100,000, a million people a year called. Now we're talking 3-4 billion. Can you imagine? let alone the damage it's done in terms of what weather conditions going to be like, how you're going to grow food in these environments, just the whole, it just goes on and on and on. Let me just also maybe make this personal, because this is what really motivates me. I look at my granddaughters. I talked about that in other videos. They're now, a little over 2 and a little over 1. And I have a great granddaughter who's almost 1. They're going to be, let's say if this happens, who knows, around 2050 or something. So they'll be roughly about 25 years old when this occurs. I look at the effort that the parents are spending, how much time we're spending, how much the family is. I look at all their friends that bring their young kids over for gatherings periodically, and how concerned those parents are, and how much time they spend with these kids. They're trying to make sure they're eating the right kind of foods. They're trying to make sure they're getting they're learning how to read and write and do other things. They're learning how to share. They're spending all this time trying to turn them into great human beings. Why? So they can thrive as adults. And what are we doing to them? When they're 25 years old, the prime beginning of their adult lifehood, right? They should be getting married, having kids, starting their careers, whatever they want to do. That's up to them. But these are prime beginning of their adult life. They spent all this time doing it, and they're going to have to try to do it in a nightmare scenario? I mean, how can I do that to our kid? That's why I'm doing this. But how can you do that to your kids? See, that's why I want you to create your family tree, climate family tree, so you could look at that and say, is this really the environment I want to leave them 25 years from now? Really? Let me just move on. So what happens at 4%? At 63.7 degrees Fahrenheit, the world is a planet unrecognizable to humans. Do you hear that? Unrecognizable to humans. The world is not just hotter. It's fundamentally different from anything humans have ever experienced. Cities, infrastructure, food systems built for the Holocene, that's the last 10,000 years, will not function in these conditions. The level of warming could make large-scale human civilization nearly impossible to sustain. And when is that going to happen? Probably between 2067 and 2073. Yeah, my grandkids should be around 50 then. That's the prime of their adult life. And they're going to try to survive in a planet that's unrecognizable to human beings. I mean, how can we do that to them? How? And if you don't think the science is true, look at these damn presentations I'm doing here. You all have access to artificial intelligence, search engines, etc. Use them. Check it out. Folks, this is serious. Let me just wrap this up before I go crazy here, okay? So here's the summary of what I just said. And I showed it, what the scientists say are going to happen these levels, when they could probably happen. Actual probably somewhere between the 10-year average and the accelerated growth rate. And I just think the conclusion is just obvious. We need to get the net zero greenhouse gases, not 30 years from now as fast as humanly possible. And if you're sort of still fuzzy about how that's even possible, you really need to look at video 4C, where we talk about the structure and operations of Earth's climate system. So let's wrap this up. It's probably been a pretty depressing video right now, right? So the goal of this presentation was sort of make the scientific and evidence-based cases why we need to get to net zero greenhouse gases now. And by now, I mean as fast as humanly possible, and I understand. It's going to take time and money. We have the video 7 here, the climate family tree. If you watched this video and didn't complete that in advance, I suggest you look at that video, create your climate family tree, and go back and watch the back end of this video again. So you can look at that tree and look at the evidence, and look at the tree and look at the evidence, okay? And then what you're really going to have to do is you're going to have to say, is this guy right? Well, there's even a 50% chance this guy's right, or 75% chance this guy's right. What am I going to do about it? This is really a depressing video, so let me wrap on a more optimistic note, okay? You wouldn't believe it, but I'm actually a fairly fundamentally optimistic person. That's why I'm doing these videos. I'm trying to say, hey, we can do something about this, folks. Human beings are just really, we have been, if you look at the history of our race, the human race, we've been really creative. We've been able to figure out all kinds of ways of dealing with problems. And I believe we can still do that with this. The fundamental problem is that we don't agree we have a problem. And that's what I'm trying to do. Because I believe if we can get everybody to agree, at least most of the people to agree, that we have an urgent problem we need to address, I think we can make all kinds of progress to doing that. But we've got to reach that agreement. And so that's for my final message. So what do we need to do here? Well, one of the things you're going to need to do is vote. I mean, this is not going to get solved from the top down. Our current political leaders and corporate leaders just absolutely failed us. I mean, take one political party I can think of. I don't think I can come up with 5 people that I could list in the entire party that believe climate change is a real problem. And then we have the other party, and so my solution is, let's just replace them all with people who really care about the environment, take this seriously, and are willing to do some action to do that. And the only way we're going to do that is we just need to vote in every single election at every level of government for people who believe this is a problem, because we're running out of time. We have kicked the can down the road on this so long that we're basically almost out of road. You could also subscribe and other things here, but let me just wrap this up with that and say, I'm sorry this took so long, and I'm sorry I was maybe a little bit too passionate at this, but I'm just trying to convey what I believe is the truth here, folks. And thank you for spending some time with me if you made it this long, and please join us for one of the other videos.